Hi guys, so we have an O-level past paper question from the year 2016. The session is May-June. This is question number 11. This question is based on mensuration. So let's get into it. In the question they've given us two cylinders. The question reads solid I is a cylinder with a small cylinder removed from its center as shown in the diagram. The height of each cylinder is 20 centimeters and the radius of the small cylinder is r centimeters. The radius of the large cylinder is 3.5 centimeters greater than the radius of the small cylinder. The volume of the solid I is 3000 centimeter cube. Calculate R. What they mean to say is, if you find the volume of the entire shape and subtract the volume of the smaller cylinder inside, we would get 3000 centimeter cube. So let's write it down. First of all, let's write down the radius. The radius of the small one is r centimeters. The radius of the larger shape is r plus 3.5 centimeters. So the net volume is equal to the volume of the larger shape minus the volume of the smaller shape. Now the net volume is 3000 centimeter cube. That's given to us in the question. We use pi as it is, and instead of r we use r plus 3.5 whole squared times 20 for the larger cylinder minus pi times r square times 20 for the smaller cylinder. So let's do this further. We have r plus 3.5, which means I can take out 20 pi from this and solve r plus 3.5 whole squared minus 20 pi from this as well and r squared separately. Okay, from the entire equation what I can see is 20 pi can be taken out from the entire equation. So I do that first. 20 pi comes out of the brackets. What you are left with is r plus 3.5 whole squared minus r squared. Okay, now we need to open up this bracket and expand this. So what do we get when we do this? So 3000 equal to 20 pi. Inside the parentheses we have r square plus 7r plus, let's do 3.5 whole squared. 3.5 times 3.5 gives us 12.25. Okay, minus r squared. This is what we are left with. Now the r squares cancel each other out. 3000 gets divided by 20 pi and this would be equal to 7r plus 12.25. So 7r is equal to 3000 divided by 20 pi minus 12.25. Okay, let's plug this into the calculator. We have 3000 divided by 20 and let's use the symbol of pi, and we get 47.746 minus 12.25. This is equal to, we have 3000 divided by 20 times 3.142 and we subtract 12.25 from it. We have 35.49. So 7r is equal to 35.49. R would be equal to what? Let's see. R is equal to 5.07. So the value of R, you write it over here, 5.07 centimeters. The next part says solid 2 is a cone with volume 3000 centimeter cube. The perpendicular height of the cone is twice its radius. Which solid is taller and by how much? So they are comparing this solid to solid 1 on the first page. So first of all, we need to look at this information. Height of the cone is twice its radius. That means h is equal to 2r. So how do we find the volume of the cube? The volume is given to us. However, we plug the formula in over here, which is pi r square h over 3. This should be equal to 3000. When we do pi r square times h in this case is 2r. This is equal to 3000 times 3. Okay. So the next thing is we do 2r cube is equal to 9000 divided by pi, and 2r cube is equal to 9000 divided by 3.142 and we get 2864.4. r cube is equal to divide this by 2 and we get 1432.2. So that means you find the cube root on both sides and r would come out to be, let's find the cube root on both sides, 1 second. So we have this value 1432.2 and the cube root comes out to be 11.3. So r is 11.3. That means the height, which is 2r, is double of this. So you multiply this by 2. So the height of the second cylinder is 22.5. This is for solid 2. For solid 1, the height was 20 centimeters. So we write 20 centimeters for solid 1. And of course, the second cylinder is taller. So we write the value over here. Solid 2 is the taller. Solid 2 is the taller by 2.5 centimeters. When you subtract this, you get 2.5 centimeters, of course. Okay. The last part says the diagram shows a triangular prism of length 24 centimeters. Its cross section is an equilateral triangle with sides 8 centimeter. Calculate the total surface area of the prism. We have to find the area of all the sides in this shape and add them together. So the rectangle, there are 3 rectangles, though that's going to be easy. So let's find the area of the rectangles first, which is length times width, which in this case is 24 times 8, and you multiply it by 3 because there are 3 of these rectangles. So you do 24 times 8, 24 times 8 times 3, you get 576 centimeters square. Now we have 2 triangles. And since these triangles are equilateral triangles, so what I mean to say is this side is 8, this is 8 as well, but you don't know the height in the middle. So what you do is you use 4 over here and you use 8 over here, and you can say that this is h, and you use the Pythagoras theorem to find h first. So we do 8 square equal to 4 square plus h square. So 8 square minus 4 square should be equal to h square. H square is, let's see what it is. 8 square is 64. 64 minus 4 square is 16. You get 48 over here. And the square root of 48, when we find the square root of 48, we get 6.93 centimeters. Okay, that's not the final answer. Now we find the area. We have half times base, which is 8, times height, which is 6.93, and you multiply this by 2. Why? Because there are 2 triangles. We multiply this by half times 8 times 6.93 gives us 27.7, which times 2 gives us 55.4 centimeters square for the triangles. This is for the rectangles. Now let's add them together. 576 plus 55.4, and we get 631.4 centimeters square, which is our final answer. So we write it over here, 631.4. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.